Hi, I'm Mrs McTaggart, and this is the first in a series of lessons on the wave function. So this is part 1, where we will focus purely on one of 4 different expansions we could use. We will be looking at the ones where we are using cos bracket x minus alpha, which is classed as the easiest one, so a really nice place to start off. And what I've done is I've kind of split the video into 2 parts, and there will be certain bits where I'll say stop and go try the following questions from the TJ textbook, because that's the book that I kind of work towards, and then I'll start and do the second half and then get you to go try some others. So what we have here is we have the graphs of sin x and cos x. What the wave function asks you to do is it asks you to express these 2 graphs added or subtracted. So it asks you to express cos x plus sin x in the form of kCos x minus alpha. So what it's actually looking for is it's looking for the combined wave that comes out when you add these 2 graphs together. Now you might be asking, oh, what on earth, how on earth can you add these 2 different graphs together? But let me just show you what it looks like. So this orange wave is now the combined wave of the sine and cos graph. Now looking at it, you can see a couple of things, like the amplitude of it is bigger than 1 now. So the amplitude has increased, okay? Now we call the amplitude this thing called K. Some other people might use a capital R instead. And you'll notice it still has this lovely cosine or sine shape, doesn't it? It's still got this continuous wave pattern going on. Now, you should remember from maybe National 5 or even just higher, when you're talking about cos and sine graphs, you can look at a graph and there's 4 different possible equations. It could be a sine graph, move left to right, or a cos graph, move left to right. And at National 5, we always told you which one to go for. At higher, similarly, we do the same. We ask you which one to write this combined wave as by asking you to write it in a form. And like I just wrote in the previous slide, we wanted you to write it in the form of k cos x minus alpha. Now that's what we're going to do today. In next bits I'll do that is x plus alpha, and then in following videos we'll change that cos to a sine. So we're just focusing on one expansion at a time. And then you'll notice this looks a wee bit like the expansions you learned when you were doing the double angle formula or the addition formula. So let's put it into some general terms for you then and get on to the method. So for the questions I'm going to be doing, this is what they're going to be. I'm going to give you something cos plus something sine, and we have to write it as cos x minus alpha. That is the equation of our new combined wave. And then once we find that out, we'll ask you things like the new maximum or minimum. We'll ask you to then solve an equation. We'll maybe put that equal to the number 2. So k is basically an amplitude of the combined wave, and alpha is the phase angle. That's how much it's shifted left or right. And what I've done is I've kind of break it into kind of steps, so we lay out the working. So here it is. So this is just for a general one. So it's a cos x plus b sin x. So this isn't a real example. Right, so what we do is, the first thing we do is, step 1 is we expand this cos bit at the side. So we're going to rewrite this as k cos x, cos alpha. Remember the expansion, the minus becomes a plus for cos, and that will become k sin x sin alpha. I'm squeezing it in a wee bit. Step 2, we then compare coefficients. So what that means is we're going to do a wee bit of underlining, right? So I'm going to take my red pen and I'm going to underline cos over here, and I'm going to underline cos over there, okay? And if you look at it, on the left-hand side, this cos here is with cos alpha and k. So k cos alpha equals whatever is with the cos over here, which is a. So k cos alpha equals a, the number in front of cos. Then I'm going to change my colour pen, and I'm going to underline sin x. And I'm going to underline sin x. And then you'll notice sin x is with k sin alpha, and sin x over here is with b. So k sin alpha equals b. So k sin alpha equals whatever's in front of sin. And that will change depending on the expansion we're using, okay? From there, to get k, to get your amplitude, we have to do a wee bit of Pythagoras. So you take your values of a and b, and you put them under a square root, you get your answer. If it's not a nice answer, you leave it as a surd, okay? So that's what you would do in there. If it's something like square root 100, fine. If it's square root of 17, you leave it as a surd, okay? So I'm just going to put that in there, that we maybe leave as a surd if necessary. You don't want to be saying your amplitude is like 2.736. And then step 4 is to find what alpha is. Now see, so this takes us back to a bit of knowledge that knowing that tan is sine over cos. So tan alpha is k sine alpha over cos alpha, and the k's will cancel out. Now sine alpha we had over here was the b. So sine alpha is b, and cos alpha is a. So whatever you'll do is you'll take these two numbers here, okay, and you'll put them in to here. And then you'll do shift tan of that and you'll get your answer. Now there's also a wee bit of ticking to do with your all sine tan cos boxes, and what we'll do is we'll tick off if sine is positive, we'll tick all in sine. If cos is positive, we'll tick all in cos, and if tan is positive, we'll tick all in tan. And then when we find alpha, we'll use whichever coordinates it's in. So we'll get our acute angle, and then we'll apply that to whichever is the relevant quadrant. So this might look a wee bit like, what is she going on about? So let's go look at it and put some actual numbers in and get on with an example. What I find is generally people quite like this because it's such a repetitive question, and it's worth some really simple marks if you get it. So, and the reason we start with the cos x minus alpha one is it's the easiest expansion to get out of them all. So step 1 was to write that in that form. So I'm just going to rewrite my question again. So we've got 3 cos x plus 4 sin x, and it would equal this, but I'm going to just go straight to expansion of that. So that's k cos x cos alpha plus, remember it's the opposite sign, k sin x sin alpha. Okay, then we do the underline a bit. So I underline cos and I underline cos, and I equate from that. So that means that k cos alpha is whatever's with the cos over here, which is number 3. Then I'm going to take a different colour and I'm going to underline the sine. So underline sin x and I underline sin x. So sine of the sine is with 4. So I've got k sin alpha equals 4. Then I do the wee bit of Pythagoras to get k. So k is the square root of 3 squared plus 4 squared, which is 25. And that gives us a nice number of 5. So k is 5. Then we're going to do the tan. So remember, tan alpha is sine over cos. So I'm just going to write this in for this, and I'll not write this again. So remember, it's sine over cos. Sine alpha had a 4. Cos alpha had a 3. Okay. So then our acute angle is shift tan of 4/3. Which is, I'm just going to do its nearest degree, is 53. So my acute angle is 53. Alright, and then I do them all sine tan cos. And this is a nice one because everything's positive. So sine is positive, all in sine. Tan is positive, all in tan. Cos is positive, all in cos. So we're actually just using our acute angle. So alpha is 53. Now the last thing to do is I always rewrite the question out. So as my conclusion, I'm going to write the following. I'm going to write 3 cos x plus 4 sin x equals, and then remember they had they wanted it in the form k cos x minus alpha. We are now just going to replace all these bits. So we now know that k is 5. And we know that alpha is 53, so it's x minus 53. And that there is our final answer. And as I said, from there they can ask you to maybe solve a little equation. They can ask you to find the maximum minimums, and I do that in another example. So there's your first wave function. Let's do another one. Okay, so this one we have got 2 cos x plus 6 sin. So I'm going to rewrite that out. It would help if I was using pen. So we have 2 cos x plus 6 sin x equals k Cosx, cos alpha, it's a really funny looking alpha, plus k sin x sin alpha. Okay, underline a bit. Cos and cos. Cos is with cos is with 2. So k cos alpha equals 2. Then I'm going to do the sine. So sine and sine. So k sine alpha. Over here on the right, sine is with sine. And on the left, sine is with 6. So that equals 6. Then we do k, so that's the wee Pythagoras bit. And you'll do 2 squared plus 6 squared, which is square root 40. Doesn't simplify. Well, it would as a third, but we'll leave it as that. An unsimplified third, we'll leave it as root 40. Okay? Then we have to go do the tan bit. So tan alpha, remember, was sine over cos. So sine over cos would be 6 over 2, which is just 3. Your acute angle, when you do shift tan of the number 3, gives you, to the nearest whole degree, gives you 72. And then we do all sine tan cos. Now, to be honest, see if everything's positive like it is in this one. It is always going to be the all box. But just to go through the motions. So, cos is 2, which is positive, all in cos. Sine was 6, which was positive, so all in sine. And tan was 6 over 2, so positive, so we do that. So we're using that one there again. So alpha is 72. And remember I said my last step is to go rewrite the question. So 2 cos x plus 6 sin x equals, and then this bit up here, we're rewriting that in the right form. So k was root 40, cos bracket x minus alpha, which was 72. And that is us done our second wave function. Okay, so I've just put in a little part B for that question that we just did. So it's asking us to write down the coordinates of the maximum and minimum turning points of the equation y equals 2 cos x plus 6 sin x. Now you might recognise that was what we just did in the previous question, and we said that that was the same as root 40 cos bracket x minus, and what was the angle again? It was 72. So we said that was x minus 72. So that is the same thing, and this is why we're doing the wave function. So to get the maximum minimum turn points, we need to remind ourselves of our basic cos graph. So here is our basic cos graph. Maximums normally appear at 0 and 360, and minimum appears at 180. So all we have to do is figure out what's going on with the shift. And the easiest way to do that is you put the bracket equal to these important numbers. So to get the maximum, you put x minus 72 equal to 0 and 360. So taking the 72 over, that gives you x equals 72. And then it gives you 432, which is too big because remember the graph was between 0 and 360, the wee bit we had up at the side. So I don't need to bother putting in that second answer. So that means my maximum turning point is along 72 and then up as high as your amplitude. Now in this example, ours was going as high as root 40. So that would be your maximum turning point of the graph that has moved. Then similarly, to get the minimum, you would put the x minus 72 equal to 180. You would move the 72 over, giving you 252. So the minimum turning point now happens at 252, so along 252, and it goes down to negative 40, which is from your amplitude. So that's the spin they put on these questions. So at this point, it might, if you're using the TJ book, this might be a nice place to stop and go try some of these very basic ones. What I suggest is doing is on page 157 is I would try question 2, maybe just do a couple like A, C and E, and then question 3. Okay? Okay, so then we'd come back and try another 2 examples. So example 3, you notice this one's, the only difference is we have a negative in the equation now, but we still do everything else the same. So we start with 5 cos x minus 12 sin x equals, and we're going to expand our cos, so that gives us k cos x cos alpha. And then when the minus turns to a plus, k sine x sine alpha. Okay, so we're going to work out what k cos alpha is and what k sine alpha is. Then we're going to find k by doing a bit of Pythagoras. And I'm going to go do my underlining now. So, cos is with cos, and cos is with 5. So k cos alpha is 5. Sine is with sine, and sine is with, careful this time, negative 12. So we finally got one with a negative in it. So from there, our k is square root of 5 squared plus minus 12 squared, which gives us 169, which is 13. So I've got a nice number this time. Then we go do the tan. So this is where something's going to change. So remember, tan was sine over cos. So please make sure you get these the right way. So it's minus 12 over 5. Now, this time, when you do shift tan of 12 over 5, you get 2.4. And you do shift tan. To nearest whole number, we get 67 degrees. So my acute angle is 67 degrees. But that's not the angle I'm going to be using this time. So let's do the ticky bit. So cos was 5, so cos was positive. Sine was negative 12, so sine was negative. So you don't tick all in sine, you tick tan and cos. And then your tan fraction was minus 12 over 5, which was negative. So again, you don't tick all in tan, you tick sine and cos. And we choose the one that's got the 3 ticks. So we choose the cos. So alpha is, remember the cos box, you do 360, take away your answer. So in this case, alpha is 293. So the last step is I always like to rewrite the question. So 5 cos x minus 12 sin x equals, and we're going back to this bit up here, k is 13 and alpha was 293. And then that is the answer that we are after. Okay, let's do another one. Now we need to be careful with this one because it's in a wee bit of a jumbled up order. All the ones I've shown you so far have had cos and in the order cos and sine, and the cos has always been positive, and this one cos is negative. However, we're going to go as normal. We're going to rewrite this as root 3 sin x minus cos x equals your k cos x cos alpha plus k sine x sine alpha. Alright, and then we're going to get k cos alpha, and we're going to get k sine alpha, and then we're going to do k using a wee bit Pythagoras. Right, underline a bit. So, cos is with cos. Cos is here this time on the right, not the left. Cos doesn't have a number in front of it, but it does have a minus 1. So cos alpha is minus 1. Our sine is with sine, and over here, sine is with root 3. So sine is root 3. So our Pythagoras bit is going to be root 3 squared plus minus 1 squared. I don't know, I keep changing the order I do this in. Now root 3 squared is just 3, and minus 1 squared is just 1, so it's just 3 plus 1, which is 4, and we know that the square root of 4 is 2. Right, our tan alpha again is different on this one. So it's sine over cos, so it's root 3 over negative 1. And then we're going to get our acute angle, so that's shift tan of just root 3. So shift tan, oh I should know that from exact values, shouldn't I? It's just 60. So my acute angle in this case is 60. Now, all sine tan cos, the ticky bit. Cos was negative this time, so we tick sine and tan. Sine was positive, so tick all and sine, and you can probably see where this is going. Tan was a negative fraction, so tick sine and cos, and we use the one with the 3 ticks. So alpha in the sine box is 180, take away your acute angle, which is 120. So to finish the question off, we say that root 3 sin x minus cos x equals 2 cos x minus 120. And that there is our final answer. And then part B, we're going to go on and do what we did in a previous example. We're going to write down the maximum, minimum turning points. So this was the equation we just did before. So this we just solved to be 2 cos x minus 120. So that's what we've defined the maximum, minimum turning points of. So remember, just a wee reminder of your cos graph. Maximum at 0 and 360, minimum at 180. So my maximum should have been at 0 and 360, but we've got x minus 120. So you do x minus 120 equals 0 and 360. Move the 120 over, so you get 120, and then you get 480, but that's too big because we're only looking at between 0 and 360. So our maximum turning point is along to 120 up to the height of the amplitude, which was 2 this time, because the k was 2. So it's along to 120 up to. Our minimum is putting the bit in the bracket equal to what the minimum should be at, which is 180. And that gives you 300. So the minimum is along to 300 and down to -2. Okay. Okay, and at this point I would suggest continuing with exercise 16.1, and I would say to go try question 4. Again, maybe just a couple, so like A, C and E. And then possible extension work would be to go back onto A, C and E and find the coordinates of the maximum and minimum turning points, just like I did in the last, you had to do it in the last wee exercise. So see how you go with that, if you've got the TJ book, that is. So I hope you followed that and understood it okay. Thanks very much.